Hello and welcome back to Business Statistics. Today we're covering Chapter 12, which is all about simple regression. Now look at covariance. The linear relationship between x and y is called covariance. So if x and y move in the same direction, it's considered largely positive, and if x and y are moving in opposite directions, then it's considered largely negative. The correlation coefficient gives you a value between -1 and 1, where you can see if the number is negative, then you have a negative correlation. And if the number is positive, obviously you have a positive correlation. So to calculate this in Excel, there is a useful YouTube called Covariance and Correlation Coefficient using Excel by Linda Williams that you might want to check out. Now, we can look at it in Excel together, so let's do that next. Now, if we look at the values here, there is a simple formula in Excel for correlation where we can just write equals CORREL, and then we select our column of data first between, in this instance, B2 and B10, comma, and then the next column of data where we select D2 through D10. In this instance, the correlation is negative, and it's giving us a value of -0.06. Now, this is not always a bad thing to have a negative correlation. For example, in investments, if we have mutual funds that have several of the same stocks, then we would consider a negative correlation a good thing because we do not want to hold all our eggs in one basket. Now, similarly, there is a formula in Excel to figure out the covariance. In this instance, we write equals covariance.s if we're using a sample and .p if you're using the population. We are using here a sample of a small amount of values, so we're going to write equals covariance.s, then again select our values B2 through B10, comma, D2 through D10. And here it's given us a negative covariance of -52. Now we test the significance of the population correlation coefficient that we call rho. There is a 5-step test that we start by stating the hypothesis where H sub 0, the null hypothesis, is rho equals 0, and the alternative hypothesis is H sub A, where rho does not equal 0. The test in statistics that we use is T equals R times the square root of n observations minus 2 divided by 1 minus r squared. Here we're trying to determine a simple linear regression where the dependent variable is usually y and the independent variable is usually x. Note that regression analysis is the technique that we use in statistics to relate the dependent variable and the independent variable. Now, if you work in a company's finance or accounting department, they will often use regression analysis of your data to validate what you're presenting. So this comes in handy when trying to present data that you have collected. Now, the simple regression model formula is going to look like this. So this is y equals to the mean of the y-intercept at x plus your error, denoted by e. You can also write it by beta sub 0 plus beta sub 1 times x plus e for the error, where beta sub 0 is the y-intercept where x equals 0, and beta sub 1 is the slope or change in the mean of y per unit of x, plus e for the error. Now we can just insert a scatter plot graph from the data we looked at previously by selecting the data. All you have to do is go to insert, select as a scatter plot graph right here, and come up with the data. So note here I have graphed a scatter plot graph that shows you the points that we selected, and as you can see, they're kind of all over the map here, but this is what a scatter plot graph looks like, and it's often used to represent the data you have collected and represent what the correlation and covariance might be. Now, there's in this chapter, we also look at the mean square error, also known as MSE, which is calculated by the sum of square error, SSE, divided by the number of observations, n minus 2. There is a useful YouTube on this called Excel 2010, Sum of the Squared Residuals by David Hayes, that you might want to take a look when doing the homework for this data. Now, there's also the least square points estimates that we can calculate, and there is a useful YouTube on this as well called The Least Squares in Excel by Megan DeWitt. If you want to look at that while doing the homework for this chapter, I think it would be very helpful. Hope you have a good one, and we'll meet again for the next chapter in business statistics.